It all depends on the chapter. This one is a fairly short chapter. But sections 1, 2, and 3 are grouped together really nice to where it's kind of like a nice break to take a quiz. Okay, so we're going to talk about 2 more points of concurrency today. So the first 2 items we're going to talk about are those ones up top, the median of a triangle and the centroid. Okay, so median of a triangle. Have you ever talked about what that is? Ooh, the middle. I like that. Okay, so it is a segment. So we have a fancy word for middle if we're talking about a segment. Midpoint. Okay, so we have a segment that goes from the vertex to the opposite midpoint. Okay, so if I am a triangle and I take this, that is a median. I'm connecting the vertex to the opposite side's midpoint. Okay? You feel tired? Because why? Jasper. Okay, now the centroid, if you were to guess, what do you think a centroid's going to be? Center, okay, the center of our going to be the intersection of all of our medians. Okay, which is centrally located. So like the centroid is where our 3 medians are going to intersect. So you can see a picture kind of down below where it says centroid theorem. Okay. This actually has some really cool properties. Okay. First of all, I think it's the nicest to look at of the 4 we're going to talk about. It's I think less complicated because we're only talking about the 3 medians. We don't have any like extra segments to worry about distances or whatever. You know, all of our ones from yesterday, we had the angle bisector, but then we also had like another segment to measure the distance to the side of the triangle. Or with our circumcenter, we had the perpendicular bisectors, but then we also had segments connecting the vertices. Okay, here we just have the medians. Okay, but we have a little bit more complicated math to do. Not that complicated, but we have to sort of think about some ratios here. So what this is saying is that the centroid is 2/3 of the distance from each of the vertex to the midpoint of the opposite side. I really don't love that sentence. I find it really confusing. Essentially, the centroid is breaking up one of our medians into a 1/3 and a 2/3 chunk. Okay, so if I take like this right here, if I talk about AE. AP would be 2/3 of that whole median. Or I could say PE would be 1/3 of that whole median. Yes.
So if we had defined PA, we were given the number for AP.
Mm-hmm. So this is 2/3, this is 1/3.
So it's true for every single median that we have.
Yes. So I'm gonna write this. AP is 2/3 of AE. And I'm gonna write that PE is 1/3 of AE, okay? Because I want you to understand that if that's only 2/3 of it, then the other portion is 1/3. So together they make a third. Yes. Yes, we'll be able to tell.
Okay.
Yeah. So and it's the one from the vertex is gonna be the longer piece, the 2/3 piece.
Oh,
Okay.
so we don't have to assume.
Well, I mean, there's your assumption that it's, so yeah, take out the word assume. We know it's from vertex to centroid. Presley, did I answer your question? Okay, great. So we are gonna draw two really awesome pictures. So make sure that you leave room to draw a second picture, okay? So I'm gonna draw a triangle. And it's gonna be RST. I was more thinking like alphabetically. Just ignore them. It's fine. I'm just kidding, Harvey. That's a Q in the middle for the centroid. If you can't move that.
I thought it was like a 2.7.
The science. I think it's a U because the bottom was W.
So
Or
S
A
and
would be
R
the
has
bottom.
the midpoint of U. R and T has a midpoint of W. Is that your question?
Remember if U was created because someone accidentally misprinted an A?
I don't think so. I don't think so. But you realize that we have a U and a double U.
Yeah, that's what
Sometimes
sometimes.
people call their users like.
Huh?
All right. Now, what I'm going to do, I'm going to say, hey, UT is 21. So I'm going to highlight UT in red. Okay, if UT is 21, what is a third of 21? 7. So we could say that, okay, UQ is how long? 7. And how long would QT be? 14. Okay. QT is 2/3 of 21. UQ is 1/3 of 21. Okay. Now, I'm going to draw in that SQ is 8. If SQ is 8, I want to know what QW is. How'd you get that, Presley? Okay, if SQ is 2/3, QW is gonna be 1/3. 1/3 is half of 2/3. So if this is 8, this is 4, okay? For a total of SW would equal 12.
I see this and I need to work on the process to myself, how I know it's 4 if I don't know that whole segment is 12.
So you can do one of two things. You could say, you could solve an equation saying, oh, 2/3 times what gives me 8, which means you're multiplying 8 by 3/2 to get it. You could say, all right, well, SQ is 2/3 of our segment and QW is 1/3. Well, 1/3 times 2 gives us 2/3. So we're gonna know that whatever this 1/3 segment is, this 2/3 segment has to be double. Okay, now what if I said that QV is 5? Ah, RQ is 10. How'd you get that?
That's the 2/3, so then, double.
Okay, so if I have the 1/3 part, we're gonna double it to get the 2/3 part. Great. Okay, and so then RV would be what? 15. Okay. All right, we're gonna draw a second picture. We're gonna do some algebra. I know you love algebra. So we're gonna name this one Stew. Okay, so I'm gonna give you a little bit of time to draw the picture and write down the information I have in purple, but we are gonna do this together. Okay. I have given you the measure of VZ, which is this guy right here. And I've given you the measure of ZU, which is right here. If I want to solve for X, Presley, what do you think? What do you think about Presley's suggestion? Like it?
Yeah.
Okay, so what Presley said is we need to double this VZ to set it equal to ZU. We know that ZU is twice as long. So if I'm going to set them equal, we would need to double the shorter one, set it equal to the longer one. I'll let you go ahead and solve for X, please. What do we get for X? 5. So we have 4X plus 14 equals 10X minus 16. So what I probably would have done is I would have said 6X equals 30. So X equals 5. Good. If I asked you to tell me the length of VU, could you do that? Yeah, you could plug X back in, figure out the parts, and figure out how long that segment is. Okay. All right, so let's go back to right above there and talk about an altitude of a triangle. Now, you've heard of an altitude of a triangle. Whether you remember it or not, I don't know. It is the height of something. So if we're measuring the height of our triangle, we are drawing a segment from the vertex to the opposite side, but it has to be perpendicular, because anytime we measure distance, we want that distance to be perpendicular. Okay, if we're talking about going from a point to a segment, which we would be here, we need it to be perpendicular. So if I draw a triangle, okay, and if I'm going to draw an altitude, I'm drawing from the vertex to the opposite side, making a 90-degree angle.
Yeah.
Okay. Anyone want to guess what the orthocenter is?
Is it the center of all of the altitudes from?
Yep, it's the intersection of our altitudes. Okay, now we go to the orthodontist to get our teeth perpendicular to our gums. Do you agree?
Yeah.
So orthocenter, we're talking about those perpendicular altitudes.
What does ortho mean if it's added to something?
Straight.
Oh,
When you talk about vectors, you'll talk about orthogonal vectors. That means vectors that are perpendicular. Okay. Little preview for you there of some pre-calculus. All right. So if you go to the next page, we have a picture of an orthocenter. Okay. There's really not a whole lot special about an orthocenter. Like, we don't have any theorems about it. It's just a special point where if you draw all of the altitudes, they're going to meet. Now, here's the crazy thing. These could meet inside or outside of your triangle. Okay, so I'm gonna attempt to draw a picture of when they meet outside. Okay, this is the one point of concurrency that might not be inside your triangle.
That's the kind of meaning by
What kind of triangle do we need to draw?
I don't know what's called as a room, the I'll say not the hypotenuse, but the straight line goes over it and then it comes back into down, so the altitude that the top one is down.
Okay, so what I want you to do is I want you to draw an obtuse triangle. Draw an obtuse triangle.
Yeah. And then you have to measure the altitude. Oh, that goes outside.
Okay, now if I'm gonna draw the altitude from this like bottom vertex point, that's easy, right? Because I'm just gonna, okay, I'm gonna draw a segment that is perpendicular. I can do that. Now, why can I not draw a segment from here to here that is perpendicular? Because this is an obtuse angle. So what we're gonna have to do is we are going to have to extend our side so that we can draw a perpendicular line. Don't like this.
This part is.
I agree.
Why?
But,
Otherwise, we can't make a 90-degree angle.
wait, if it's like that, does it have to go like really far down?
Well, hold on. I'm also going to extend this side so that I can draw. So I'm trying to like draw it to here, right? I can't make a 90-degree angle until I'm like there. Nope.
It makes sense. It has to be a straight line.
Now, didn't I say these were going to intersect? Orthocenter. There's the orthocenter. There's where our altitudes are intersecting. So if you have an obtuse triangle, it's going to intersect outside of the triangle, which is lame. If it's a right triangle, they will intersect on the triangle.
What's
Yes.
the difference between a center spelled ER and a center spelled RE?
I am a math teacher. Okay. I think we've done enough to where we can get you started on the homework. If you turn to pages, would it be 8 and 9? So, like, I could not make a perpendicular line here. So I had to extend this side so I can draw a perpendicular line. You see how I just took this side and I just made it long?
Wait, can we do the practice? Yeah.
So page 8 and 9 are your homework.
A segment joint. You know what that is.
Yes. Otherwise, I want to give it to you.